Hello, algebra students. I really want to make the case with you that distribution is nothing more than what we've been doing since third or fourth grade with the multiplication algorithm. So follow me here. First example here says multiply without a calculator. I would like you might know another way, but I'd like you to use the standard algorithm here just so that I can prove something to you. So I'm going to write 143 here and multiply it by 4. And if you're old like me and you were in the age of pagers, then you know 143 is I love you. And I do. I love you guys. But what I wanted to remind you is that when we multiplied, we've always passed out. We would take, for example, the 4 down here and multiply it by the number in the ones column, in this case 3. And we would say, hey, that's 12 ones, or 2 ones and a 10. And we would carry that 1 into the tens column. And then we would say, hey, now we're going to do 4 times 4. But it wasn't really 4 times 4. It was 4 times 40, because this 4 is in the tens place. And so we're doing 4 times 40, or 4 times 4 tens. And of course, we get 16 tens, or 16. And we would add in that one more 10 for a total of 17 tens, which is the same as 7 tens and 1 100, or 100. And so we'd carry a 1 in the next column, in the hundreds column. And then we'd move on that way. So passing out that 4 to each digit above. And then we would say, well, this is 4 times 1. But really, it wasn't 4 times 1, right, guys? That 1 is in the hundreds place. So what I'm saying is 4 times 100. Well, what is 4 times 100? It's 400. Add in my 100 that I carried from before, and I'm looking at 500, or a 5 in the hundreds place. So we've been passing out the 4 all along. Now, I want to look then at another way to think of this. Okay, I would never write it this way because it's not the fast way to do it, but I want you to mentally see this. All right, so another way to think about 143 is as 100 and 40 and 3. They call that the expanded form. I don't need you to know that name. Again, this is not an efficient way to do this. We prefer the first way we did it. But I want to just show you here how if we simplified this sucker by the order of operations, we'd get the same answer. Because if we did the order of operations, we would come in here and deal with the groupings first, right? 100 plus 40 plus 3, of course, is just 143. And if I were to multiply that by 4, well, we already did that work. 4 times 143 was 572. And you can do it in your calculator if you're struggling to believe me. I realize, I get it. We have trust issues around here. But next I want to look at if I used distribution instead of the traditional multiplication algorithm. And I'd kind of like to argue that it's the same thing, just my work is organized a little differently. So in this case, I have my 100 plus 40 plus 3. And instead of using the order of operations and dealing with the grouping first, I would like you to use that lovely distributive property that we talked about that says you're going to get the same answer if you pass out the multiplication to all the terms. And again, this is not how I do it. If I was multiplying by hand, I'm just trying to show you something. So of course, 4 times 100 is 400. Kind of like we said up here when we multiplied the 4 times the 1. And then 4 times 40 is of course 160. Kind of like we said up here when we multiplied the 4 by the 40. And then 4 times 3, of course, is positive 12, kind of like we said up here when we multiplied the 4 by the 3. So it's the same 3 acts of let me say that again. So it's the same 3 acts of multiplication we did before. We just did them in opposite order. And now we're going to go ahead and add these things together. And you can do it in your calculator if you want. I'll just come over here and do it in side work. But 400 plus 160 plus 12. And look what I get. 572. So again, it's the same math. It's the same math. And this often is the way that people will do it in their head when they do mental math. It's often easier to keep track of the numbers that way rather than trying to do this in your head. But Either way, I'm going to get to the same answer. And so that's my proof for you about why this should work. If I could pass out this 4 to these 3 terms when it was plain old numbers, I ought to be able to do the same thing here. So again, it looks a lot like 4 times 143, but instead of it being 100, 4 tens, and 3 ones, this time I have 1 z squared, 4 z's, and 3 ones again. And I can pass it out. Just like 4 times 100 was 400, 4 times z squared is 4z squared. And just like 4 times 40, or 4 times 4 tens was 16 tens, 4 times 4 z's is 16 z's. And of course, 4 times 3 has always been and will always be 12. Now, before, whether we were doing the multiplication algorithm this way, or this way, there was an addition as part of it. So I should hope it would make sense to you that we see these addition signs in your expression here. However, we could combine these numbers in the first 3 examples. You know, I can combine plain old numbers with plain old numbers and plain old numbers. But here, once we reach the land of algebra, that's a difference between these 3 in that we stop. I would argue it's easier than multiplication because I just get to stop. I cannot add z squareds and z's and constant terms of plain old number. If you remember, we said we can't combine in algebra. We can't add, subtract unless the terms are unless their variable portions are identical. And so I'm done here. Easier than multiplying in 4th grade. Hey, love me some algebra. All right, proud of you guys. Strong work and happy learning.